And so I wanted to go over a few calculations with you as some sample calculations that you can see in action being done. And you're going to be doing calculations just like these. So I would advise you to take some notes as I go through these calculations. And these notes will be very helpful as you are completing your quiz. So just a quick review on conversions between mass and moles and particles, which we call atoms, molecules, or ions. Ions are also called formula units. So again, if we're dealing with conversion between grams, moles, and particles of an element particle type is an atom. A molecular compound, if it's the particle we're dealing with, then the particle is a molecule. Or if we're dealing with a compound, the type of particle is an ion or a formula unit. And so to convert between mass and moles, and of course mass unit is the gram, we'll divide by the atomic mass if we're dealing with an element, or divide by the molar mass if we're dealing with a compound. And then to go in the opposite direction, to convert moles to grams, you'll multiply by the atomic mass or molar mass. And then to convert moles to particles, you'll multiply by Avogadro's number. Avogadro's number has units of particles per mole. And then to go in the opposite direction, to convert particles to moles, you'll divide by Avogadro's number. So if we start out knowing the grams for an ionic compound like ammonium sulfate. Ammonium is a polyatomic ion, and more specifically, it's a polyatomic cation with a formula of NH4+. And then SO4 is also the polyatomic anion sulfate. So this is ammonium sulfate. Just to review our rules for naming ionic compounds, when both the cation and the anion are polyatomic ions. And so if we know that we have 15 grams of ammonium sulfate, the first question that we need to answer is, what is the molar mass of ammonium sulfate? To calculate the molar mass of a compound, we need to sum up the atomic masses for all of the atoms that are in the compound. So for ammonium sulfate, we have nitrogen atoms, hydrogen atoms, sulfur atoms, and oxygen atoms. And so in calculating the molar mass, we need to look up the atomic masses for each of these 4 types of atoms. And then we'll multiply that atomic mass by the number of those types of atoms that are present in the formula for the compound. So for ammonium sulfate, you have 2 ammonium ions. So that 2 that's outside of the parentheses is not just for the hydrogen, but is also for the nitrogen. So there are 2 nitrogen atoms in the formula for ammonium sulfate, and there are 8 hydrogen atoms, 2 times 4. And so to find the molar mass, there are 2 nitrogens, and if we consult our periodic table, nitrogen has an atomic mass of about 14. Hydrogen, there are 8 of them. And again, consulting the periodic table, hydrogen's atomic mass is about 1.01. And then we've also got 1 sulfur and 4 oxygens. Oxygen's atomic mass is 16. Sulfur's atomic mass is 32.06. And so we add the atomic masses represented by all the elements together, and that will give us our molar mass. So go ahead and do that. Does someone have our atomic mass for us? I'm sorry, our molar mass. You should have your calculator with you. I know there are a lot of students that use electronic scientific calculators, or they use an app. Either way, whatever works for you is fine. I'm old school. I still like to have the old-fashioned calculator in my hand. So now we've got our molar mass. Now that we know what the molar mass for ammonium sulfate is, now we can take the given 15 grams and convert it into moles by using the molar mass as a conversion factor. And we remember our rules for converting between units. The unit that we want to get rid of is the gram. So in our fraction, which is our conversion factor, the gram unit will go in the denominator. The unit that we want is moles. So moles will go in the numerator. And our conversion factor is our molar mass. So 132.14 grams per 1 mole. The grams cancel. We do our math. We take 15 and divide it by 132.14. And because 15.0 has how many significant figures? I know in my class we did this week, we talked about significant figures. So how many significant figures should we have in our answer? Remember when we're multiplying and dividing, we use the smallest number of significant figures that are in our multiplication operation. So 15.0 has how many significant figures? Anyone? I know I'm not in here by myself, am I? There are people here, yes. Is the 0 significant? Is that a trailing 0 or is it a leading 0? Very good, Ewan. There are 3. That trailing 0 is significant. So therefore, our answer, we need 3 significant figures. And so our answer is 0.114 moles. So now that we know how many moles of ammonium sulfate are in the beaker, how many molecules of ammonium sulfate are in the beaker? So we take the moles that we just determined and we convert them to molecules by multiplying by Avogadro's number. And the units for Avogadro's number are particles per mole. And in this case, the type of particle is a molecule. And so the moles cancel. And we take 0.114 and simply multiply it by Avogadro's number. And again, we need 3 significant figures. So 6.84 times 10 to the 22nd molecules. So that's one type of calculation that you'll have to do, starting with grams, determine the molar mass for the compound, or if it's an element, look on the periodic table and find its atomic mass, and then using that atomic mass or molar mass as a conversion factor, convert the grams to moles, and then convert those moles into particles. Here's another one of those types of calculations. This time we have an element, sulfur, and we just simply look on the periodic table. 32.06 is the atomic mass for sulfur. And of course, for atomic mass and molar mass, the units are grams per mole. And now we can convert the 55.5, sorry, I didn't change that, grams of sulfur into moles by dividing by its atomic mass. The grams cancel. So 55.5 divided by 32.06. And again, we want 3 significant figures because 55.5 has 3 significant figures. So our answer is 1.73 moles of sulfur. And then we can convert those moles of sulfur into molecules by multiplying by Avogadro's number, or atoms in this case. So when we're dealing with an element, the type of is an atom. And so the moles of sulfur cancel. So take 1.73, multiply by Avogadro's number, and you get, of course, 3 significant figures in our answer, 1.04 times 10 to the 24th atoms. And so another type of calculation you'll do is one in which you don't start with grams, but you start with moles. So if you start with moles, to convert the moles to grams, you'll go in this direction. You'll be multiplying the moles by the atomic mass if you're dealing with an element, or multiplying the moles by the molar mass if you're dealing with a compound. And then if you want to convert the moles to particles, then you'll go in that direction, multiplying by Avogadro's number, just like we did in the previous two questions. So if I start out with 0.750 moles of magnesium, looking at the periodic table, magnesium has an atomic mass of 24.305. And now that I know the atomic mass of magnesium, I can convert the 0.750 moles of magnesium to grams by multiplying by the atomic mass for magnesium. Again, I'm getting rid of moles, so in my fraction or my conversion factor, moles go in the denominator. I want grams, so grams go in the numerator. And so the moles of magnesium cancel. I multiplied 24.305 by 0.750. And I get 18.2. 0.750 has 3 significant figures, so my answer needs 3 significant figures as well. So we have 18.2 grams of magnesium. And then I can also calculate the number of atoms of magnesium by taking the moles of magnesium and multiplying by Avogadro's number. And the moles of magnesium cancel. And so 0.750 multiplied by Avogadro's number gives us 4.52 times 10 to the 23rd atoms of magnesium. Next, we have a molecule, which is a molecular compound, glucose, whose formula is C6H12O6. So by this being a compound, we've got to use the periodic table and the atomic masses for each atom and multiply that atomic mass by the number of those atoms that are in the formula. So glucose consists of carbon, hydrogen, and oxygen. There are 6 carbons, 12 hydrogens, and 6 oxygens. Oxygen's atomic mass is 16. Carbon's atomic mass is 12.01. And hydrogen's atomic mass is 1.01. And so we do the multiplication for each of those, and then we add up those three values. And you get 180.18 grams per mole for your molar mass of glucose. Now that we know the molar mass, if we start out with 0.280 moles of glucose, we can convert those moles to grams. We want grams, we want to get rid of moles. And we need to use the molar mass of glucose for our conversion factor. The moles of glucose cancel. So take 180.18 and multiply by 0.280. And again, we need three significant figures because 0.280 has three significant figures: the 2, the 8, and then the trailing 0 after the 8. The leading 0 before the 2 is not significant. So we have 50.5 grams of glucose. And then we can also take those 0.280 moles of glucose and convert into molecules of glucose by multiplying by Avogadro's number. The moles of glucose cancel. And so Avogadro's number times 0.280 gives us 1.69 times 10 to the 23rd. And that's molecules of glucose. So the last type of question that you'll encounter is when you start off with milliliters. So we have 15.0 milliliters of an organic alcohol compound called 1-propanol. And so what we would need to do is look up 1-propanol on the internet to find its density. 1-propanol has this formula, which is important. We need to know the formula because we also need to know the molar mass of 1-propanol. And so in looking up 1-propanol, I see the PubChem site, which is a site run by the National Institutes of Health, NIH.gov. So I know that's a reputable site. So I'll choose that one. And so I need to know some things about it. I need to know the molar mass. Molar mass is also called molecular weight. So the molar mass is 60.1 grams per mole. I also need to know the density. And you'll usually find density where the physical properties are listed. So we just keep scrolling down until we can find the physical properties. There we are, chemical and physical properties. There's the molar mass, again, 60.1 grams per mole. They're giving us all physical properties, the odor, the taste, the boiling point, melting point, flash point, like when it will catch on fire, basically. Because alcohols are very volatile. There's the solubility, which liquids it's miscible in, and there's density. Finally, that's what we need to know. The density is 0.803. And the density units are going to be in grams per milliliter. And we also want to know temperature. This is at a temperature of 68 degrees Fahrenheit. We're interested in the temperature at about room temperature, which is going to be about 20 degrees Celsius. And so we'll go with 0.805. We'll just use 3 significant figures. If you do a relative density comparing to water, water's density is 1. So therefore, 1 propanol's density is about 0.8. So we're going to go with 0.805 at 20 degrees, which is about room temperature. So at a temperature between 4 degrees Celsius and 20 degrees Celsius, which is about room temperature, 20 degrees, the density is 0.805. And that's what we're going to go with. And also remembering the molar mass. So we don't have to calculate it. We just looked it up. The molar mass was 60.1, I do believe. So we've got our density. And we know the molar mass. So now that we've got the density, we can convert the 15 milliliters to grams, because density is mass divided by the volume. Therefore, mass in grams is equal to the density times the volume. So the mass is going to be the density times the volume, which is 15 milliliters. And that gives us 12.1 grams. Those milliliters cancel. And we only need to use 3 significant figures. So now that we know our mass in grams, we can now calculate the number of moles by using the molar mass of 1-propanol that we got from the Pub Chem site as a conversion factor. Rid of grams, so grams go in the denominator, and we want moles, so moles go in the numerator. So grams cancel, so take 12.1 and divide by 60.1, and we get 0.201 moles. And then we can take the moles and convert to molecules by multiplying by Avogadro's number. The moles cancel, so take 0.201 and multiply by Avogadro's number. And that is an example of the third type of calculation. So for that third type of calculation, again, you're going to be given the volume in milliliters. You're going to have to look up the density of the liquid. PubChem is a great website to use. And there are other good ones as well. Just make sure you're comfortable that you're getting the density information from a trusted site. And then use the density, multiply it by the volume to calculate the mass in grams. And then take your grams, divide by molar mass to convert grams to moles, and then take the moles and multiply by Avogadro's number to calculate the number of particles. So those are examples of the 3 types of calculations that you'll encounter in today's lab. Now, I'm going to give you the option at this point, if you want to stay in the meeting room to work on your quiz individually in the general room, you can. If you want to go to the group meeting room and work on the quiz within your group, that's fine, you can do that. Or if you want to just leave the meeting room altogether and work on the quiz outside of the meeting room, you're free to do that also. So I'm going to let you make that call, how you want to go about completing the quiz today. Are there any questions? Gavin, do you have a question?
Yeah, I was wondering how many questions total there were on the quiz.
28.
Okay, thank you.
You're welcome. Yes, Ricardo, the quiz is the only thing that you have to do today. That's the only thing that you have to complete for this week's lab. There won't be anything that's required to submit to a Dropbox. Just complete the quiz. And again, you can access the quiz by clicking on the down arrow on the Activities tab, click Assessments, and then click on the Mole Lab quiz. Very important to have your periodic table next to you, your sample calculations. That PDF file on our Lab eLearn site for week 10 will be helpful. And also, if you took notes while I was doing these calculations, then you'd also want to have those notes next to you as well. So if there aren't any questions, you can go ahead and go to your group meeting rooms, or you can leave the meeting. And again, I'll be monitoring the submissions. So I'll try to get it graded as soon as possible after you submit the quiz. And then you'll have plenty of time to make a decision whether or not you need to retake the quiz. Again, your last opportunity to do the quiz is 11:59 p.m. Friday night. Hello, Madison. Again, if you need to review these calculations that I did with you, the recording will be available on our team site. So when you go into our team's general site, you look under the posts tab and you'll see the recording for today's date.
I'll take notes too, so I think I'll be okay. I think we're gonna meet in the breakout room.
Okay, very good.
Thank you.
Thank you.